Right, so been thinking about this little circuit last night, and a thought occurred to me, and I think what I need to do is I need to actually build the circuit so that we can see what is actually going on with inside of that snubbing circuit. That I think that's what they call them. So the thinking here was going to be, well, I can build the circuit actually, or I can build it virtually, and I think virtually is probably going to be the easiest, considering I don't actually have those transistors. So I use a bit of software called Every Circuit, and I use this because there's lots of it available, so and it's freely available, and if you buy the paid version like this, it's really small money. So I'm going to try and build this circuit, and I'll try and put in the values as best as I can, and then we'll see if we can simulate this and figure out why we have these little transistors in there. So here we go. So we've got a, let's start with this transistor here. I'm just going to place this one over here. Let's go for there. And then of course it had a resistor in there. Now to change the values on these, if we go back there, that was a 40 ohm resistor by the looks of that. Let's make that a 40. Nice thing with this is you can just go to town with this. No, that's a 40 resistor. Now we need to know what these values are for that main transistor. Let's go and have a look there. So that was the ZTX 450. Now I thought I had, there we go. Right, let's see if we have the values that the software needs. I'm going to put that over there so I can get to it. The first one, it wants a saturation current. Can we see that? Collector current. Yeah. Collector. Right there. Collector. Emitter cutoff current. Looks like 150 milliamps. Looking at that, let's use that. We're going to that there. Not really sure if this is the right thing, but okay. Let's use that, eh? And then it wants forward basing. So it might be 1.1 volts. Not quite sure what that is. Let's leave that alone. Ultimately, I don't really know that that'll make much difference, so let's just go ahead and use it as it is. And I want to put this one in here. What I'll do, just for the sake of having a light bulb, we'll do that. Well, let me do that. And this, can I put another ground in here? There we go. Let's put another ground in there. Okay. Got this diode that sits in there, but we want to flip it around because that's how it's wired. That needs to go to there. Let's go down to there. Except that this one is a 22 volt. Was it? 22, yes. That's enough. Okay, take this. I'm going to flip that sideways. And typically a 1K would be the trick. Now I want to flip that around to that and flip it this way. And I think from memory this was wired like this. Okay, now we do need a supply on a voltage control current source. Well, we can do that. We're going to put another ground in here. Down to there. Now I do need to go and adjust this one. Now this one here must operate from memory. Relays work from about 7 volts. Release voltage. Let's do that. Make that 12. Oh, that's not 12, is it? Yeah, that'll do. Yeah, that should be fine. That should be fine. And then what we want to do is we want to attach that to that. And we want to make this 12 volts. Okay, right. Now if we put in for the sake of testing, what we'll do is we'll put in a switch here. And I'll put in another power source. And this one we're going to set to 5 volts. So if we go and simulate the circuit, do that. We're going to simulate the circuit. See how? So that's working. Why did that not pull in? Actually, bring this down to there. Interesting. Why did that not pull in? It's 10. Well, inductance. Well, resistances now are probably more likely to be about 200 or 300 ohms. Let's see. This is bizarre. Why is that relay not working? I wonder if it's because this ground and that ground's not connected. No, but that's... Why is there current flowing through there? One would have thought that there won't be any current flowing in there. Let's cut that wire for a minute and grab a switch. Attach a switch in there. Oh, that bulb's on fire. Oh, I wonder why. Maybe it's because the voltage is only... Let's give it a 12-volt bulb. Here we go. There we go, and 20 watts, just so we have something to work with. So if I shut this down now, that'll happen. Right, so let's join that to that, to that. Oh. Pause this, so we can now try and join these two. Right. Let's see, and it doesn't work. Voltage is, that's 7 volts. Let's come down to 6 volts. And the release voltage, let's make that back 3. It's completely bizarre why this won't work. If I switch that one on, it does. I wonder if this is the problem. We did change that, didn't we? I think I'm going to have to figure this out first. And we'll have to come back and see what is causing our issue here. Okay, I think I figured out what was wrong. It was somewhere in the relay there was a a problem. So what I've got is I've got a little switch here so I can turn the circuit on and off. And as you can see, as I energize this part of the circuit here, the relay gets activated and turns a little light bulb on for us. So what I want this to do is I want to actually watch just this circuit here. And what this will do now is it will monitor the voltage on that circuit there. So if we turn the circuit off, you can see we've got a 22 volt 22 volt spike, and that's because of that there. So if we run that space again and we just enable this switch here, pulls down, and the circuit starts running. I'm still not sure about this 5 volt here. I think this is not quite switching on as low as I would like it to be. But then, you know, we've got this resistor over here that's limiting the current. So what we can do is we can put in a we can monitor this circuit as well here, which we will do with the green wire. So let's have a look and see what happens here. So the circuit's operating, turn it off, and we've got this little voltage spike that happens over here. Let's make it a nice slow time base and see what happens when we energize this. Yeah, as you would expect, a little bit of a voltage drop. There's only so many volts there. But that's nowhere near enough to activate that relay there, that transistor there. Unless when we turn it off, it just goes down. So I can't understand why this needs to be in there. What is the function of that? I wonder if it is for that, if that fails. So let's put in a switch. And this is now just purely to see what's going on here. I'll put this in there, take that wire, no, just that wire, we'll cut it. Put the switch in there. We'll have that switch open. Turn it on. So I've now taken the back EMF control away. Even that. Even that doesn't make any sense. I know that bit works. What I don't see there is the back EMF. There. And I really thought I would have seen that. So, I wonder if it's in the settings for that. What does that do to the current there? Has it gone up? No. The saturation current, it's not going to change that, is it? I suspect this here is to current limit that. But that transistor can handle an amp. Why not just run it straight to ground? I need to go and think about this for a little bit more. There must be something really, really simple going on here. Right, I actually see what's going on here. This transistor is current limiting this transistor, and I'll show you what I mean by that. If we watch the green line, which is the amperage up here, that is flowing through this transistor here, at least sorry, this one, you'll see how by changing its values, we are changing the current. So at the moment, I'm just changing the emitter resistance. And see, as I bring the emitter resistance down, the current is coming down. So let's say it's 400 ohms. This circuit here is controlling the amount of current that this transistor needs to deal with. So if we open that circuit, you can see that, so I've just taken this transistor out of this, we can see that we have, going through that transistor, we have 58 milliamps, which is about right, probably considering there's a 40 ohm resistor here. If I was to open up that switch there, and that's just here to control the, to take this out, the Zener out of the circuit. So you'll see if I open this, we've got a voltage has come back up, that's the blue line. Turn back on again, we've got 0 down there. Now if we put that on there, what it does, it gets rid of the back EMF. I'm quite far away, so we're probably not seeing that. But if we see there that the green line sits at 60 milliamps, if I enable this transistor there, it just drops it down a little bit to just under 50 milliamps. So this transistor is purely there for current control through that transistor there. So we could potentially remove that if we put another resistor, another transistor in there to have that circuit work. I'm not sure I want to do that. So maybe what will need to happen is I'll have to order those transistors, new ones, and then replace them and go from there. Before I go ahead and do that, what I'll do is go through and make sure that the board is not damaged and that all of those circuits are actually all right, and then we'll probably need to go and order those transistors and replace them with the appropriate ones, so that we know that it is back to a specification that makes sense. So at least we know what's causing that. I'm going to go and have a rumble around and see if I've got some of those components. Hopefully I do, and then we'll go from there.